Hello everyone, you're welcome to our educational channel once again. Today we shall be discussing on how to derive shear force equation and bending moment equation of a cantilever structure and how to draw their respective moment diagram. Now let's read through the following question. Derive the shear force equation and bending moment equation of the cantilever above. Also, draw the shear force diagram and the bending moment diagram of the above cantilever structure. Today we have a cantilever structure with uniform loading of 2 kN per meter and at the free end of 3 kN per meter bending moment with a length of 5 meters. And we are asked to calculate the shear force equation and the bending moment equation of the cantilever structure. Now let's pull out the parameters. On our cantilever structure beam, we have the length of 5 meters. We have the uniform load, distributed load, which is 2 kN per meter, which is UDL. We have the moment at the free end of 3 kN meter. Also, we have the Young modulus of the beam, which is 185 gigapascal. Now, in order for us to find the shear force equation and the bending moment equation, first of all, we need to resolve the references on how to calculate the forces and the bending moment. Here we have the horizontal forces, which is 0. We have the bending moment reference pointing clockwise in this direction from the hand here, and we have another one pointing anticlockwise here. Let's assume the beam is cut into a section at point X. So therefore we have 5 minus X as a length, and we have the free end moment, which is 3 kN, and the uniform distributed load of 2 kN per meter on the section beam. In order this, let's assume that summation of mx equals 0 when the anticlockwise moment turns positive. Therefore, we have negative m plus 3 minus 2 multiplied by 5 minus x, which is the distance, multiplied by 5 minus x over 2, that gives us 0. So therefore, our bending moment gives us minus 22 plus 10x minus x squared. Now let us assume again that the summation of the horizontal forces when the upward forces turned positive. So therefore our shear force, which is pointing upward, equals s minus 2 to product of 5 minus 5x, which is the distance, equals 0. So therefore, if we simplify this, our s equals 10 minus 2x calculated. So our shear force moment tends to give us this diagram below, as 10 at 10 shear force kilonewton we have 0, and at 5 distance we have 0 shear force. Also, our bending moment diagram from the equation we got from the bending moment give us this diagram. At minus 22 bending moment, we have 0 distance, and at 5 meter distance on the beam, we have positive 3 bending moment kilonewton per meter. Thank you very much.